In question 5, I'm asking you to use the graph to help you find the factors and the zeros of the polynomial function. So our polynomial function is given to us, and we're given the graph, so we don't even have to mess with decimals. And from the graph, what it tells me is we've really got a solution or two here that stand out. This one is right here. Because it is tangent to, I know it's a solution, and it's apparent from the graph that it's at 2. So that means when we use our synthetic division, we ought to be able to use that twice to get remainders of 0. This second, or this third 0, because that's going to really get counted twice. So what you count as a second or the third really doesn't matter. But this one is hard to tell where it is because it's somewhere between a -1 and 0. So hopefully that'll all come out in the wash when we do our synthetic division. So what we want to do is we want to divide by 2. That's our 0. We divide it into the coefficients of 7, -26, 20, and 8. When we divide by 2, if our graph is telling us the truth here, then we should get a remainder of 0. So we'll drop down our 7. 2 times 7 is 14. 14 and -26 is a -12. 2 times -12 is -24. Add them together gives you a -4. 2 times -4 is a -8, and we get a remainder of 0. Now we started with a third-degree polynomial. Now we're down to a second-degree polynomial. And we really could take this second-degree polynomial, write it as 7x squared minus 12x minus 4, and solve that using quadratic means. But I also have some more clues here in my graph. My graph tells me that 2 should be a factor again. So rather than doing the quadratic part over here, I'm going to run through with another factor of 2. So I'm going to take out a 7, bring 7 down. 2 times 7 is 14. Add it to a -12, which is 2. And 2 times 2 is 4. Add it to a -4, which is 0. Now I've got this down to a first-degree polynomial, which means I have 7x plus 2 that has to equal 0. This is one of my factors, one of the linear factors. We were asked to find both factors and zeros. So we have factors of, from our 2's, we have identical factors of x minus 2 times x minus 2. And since we got it boiled down to a first-degree polynomial, we had enough information here to get it down to a 7x plus 2. That is my third and remaining factor. So this is the factored form that I was asking for. I also asked you for the zeros. Well, these were the zeros of 2 and 2. The zeros for this one was, or is, remember you can take the 7x plus 2, the relationship between zeros and factors are set equal to 0, zeros are solved for x. So it'll be 7x equals a -2, x is a -2, 7. So my final 0 is a -2, 7. So here are the zeros. And those are the related factors. So I wanted both in that question because I want to make sure that you can get the relationship between zeros and factors.